about the high efficiency, low emission coal power technologies and the ongoing development and the deployment worldwide. Before I start, I'd like to talk a little bit about our center, who we are and what we do. The IEA Clinical Center is a technology collaboration program endorsed by the International Energy Agency. Our mission is to provide independent, unbiased information and analysis on all coal-related trends. We identify and publicize the best practice in the coal production, transport, processing, and utilization within the rationale of balancing the security of supply, affordability, and environmental issues. We have a wide-ranging program of work, including the policy and the regulatory considerations, the global funding options, markets, public acceptance, and a wide range of technology-related issues. Our work can be related to the 8 of UN Sustainable Development Goals at the bottom of this slide, in which the coal issues are most relevant. Our focus is on the sustainable development and the environmental issues. Now, let's move to my presentation today. And here is the outline of my presentation. The higher efficiency power units operates at, the less fuel is required, and therefore lower CO2 emission and emissions of other air pollutants for a unit of electricity being produced. These slides show the relationship between the higher efficiency and the lower CO2 emissions. The efficiency increases are based on the result of increased steam in steam conditions. The maximum steam temperature of a subcritical system is around 540 degrees C. A supercritical process operates at a steam temperature of up to 580 degrees C, where an ultra-supercritical process, which is the state of the art now, has a steam temperature of 620 degrees C or slightly higher. The global average efficiency of coal power plants has been improved over the years and is currently at 35%. This is still well below the over 47% supercritical power generation units can achieve today. This is because a large number of the old coal plants are operating at the inefficient subcritical mode. If the global coal fleet can move from where it is today to the ultra-supercritical system, the carbon intensity of coal power generation can be reduced significantly, leading to a 26% of CO2 emission reduction. And this is a potential annual CO2 savings of over 3 gigatons per year. The ultra-supercritical system require higher grade alloy materials, pushing up the capital cost. But higher efficiency means lower emissions, lower coal consumptions, which has a lower operating cost, and in time, it will pay back the investment. The carbon intensity of ultra-supercritical system is much lower, and so are the emissions of other conventional emissions, pollutant emissions such as particulates, SO2, and NOx. Equally, or perhaps even more important in some regards, if we look at the grid system globally, that is to include the even increasing amount of intermittent renewable power, such as wind and solar power. Coal power plants can be used to stabilize the grid as they are cheap, flexible, and robust. This picture here shows the Waigaoqiao No. 3 power plant in Shanghai, China, and it is a good example of a Haley coal power plant. It has two 1,000 megawatts ultra-supercritical units, which started operation in 2008 with net plant efficiency of 43%. Through a series of innovative efficiency improvement, the plant has now achieved efficiency of over 47%. German RDK-8 USC unit came online in 2013, achieved net plant efficiency of 47.5%. And also in Germany, the state-of-the-art lignite power plant can achieve efficiency of over 33%. The advances in material means even higher temperatures can now be adopted. GE has recently commercialized its steam edge technology, which pushes the physical limits of existing steam power technology with steam temperatures approaching 650, 670 degrees C, and the system can achieve a cycle efficiency of 49%. A different approach is taken in China to increase the efficiency substantially without pushing up steam temperature as much. The 1,300 megawatts USC Pingshan 2 demonstration plant has an innovative design and with a double reheat. In a conventional power plant, the steam generated in the boiler is transferred down to the turbines, normally located at the bottom of the boiler house. Because the high temperature and the high pressure, the expensive materials had to be used for the piping. And because the piping is very long, especially with double reheat, it's very costly, and also you lose some efficiency. In this demo plant, the high and the intermediate pressure turbines are put up right up to the boiler house. So the pipes transfer the steam from boiler to the turbines are minimized, resulting in a substantial cost savings and also better efficiency. This technology can add 3 percentage points of cycle efficiency. Today's commercially available technologies are capable of reducing air pollutants emissions from coal power plants to very, very low levels, which are comparable with those of natural gas-fired power plants. Japan's Isogo USC coal units achieved single digits level for SO2, NOx, and particulates emissions. In a recent battle to control air pollution in China, existing coal plants achieved emissions lower than 30, 50, and 10 milligram per cubic meters for SOx, NOx, and particulates respectively, after the upgrade and the modernization of their pollution control systems. When HALEU technology is mentioned, people often think about pulverized coal combustion. However, this one coal power generation technology has recently improved significantly, and I think it's worth of mentioning here. It is circulating fluidized bed, CFB, combustion. Since the first commercial operation of the first supercritical CFB power plant in Poland in 2009, over 24 more supercritical CFB coal power plants with size from 350 to over 600 megawatts have been put into operation. Most are in China. In addition, 550 ultra supercritical CFB units are in operation, and 2 more such units are under construction in South Korea. And this CFB units has plant efficiency of 42.4%. This slide shows an example of what a 300 megawatts supercritical CFB power units can achieve today. Considering the type of fuel burned and the air cooling is used, this efficiency and the emissions numbers are very impressive. Ultra supercritical CFB demo project is under development in China. The objective is to develop and build a 660 megawatts high efficiency, ultra low emission and energy saving CFB plants. And this slide shows the some of the design parameters to be adopted for this unit, and it is scheduled to start operation and the technical demonstration by 2020. Despite the recent significant advances, we have not reached the end of the technology yet, and there is still a lot going on. There have been new developments and innovations that have every chance of successfully taking the technology well beyond the highest achievable efficiency I have just shown. They may even revolutionize power generation. One approach is to improve efficiency through increasing steam conditions by developing better quality material. And extensive R&D has been ongoing, and some demonstration projects are under development in Asia. A different approach is to develop supercritical CO2 power cycles, and this is truly transformational. It uses supercritical CO2 as a working fluid instead of a steam in a closed or semi-closed Brayton cycle. The principal benefit of a CO2 cycle is its high thermal efficiency and moderate temperature. Several different CO2 cycles are under development now. The most advanced is the alum cycle. In the alum cycle, the natural gas or syngas from coal gasification is burned in pure oxygen. So the exhaust is a pure CO2, which is ready for sequestration. Due to the high energy density of supercritical CO2, a CO2 cycle has much smaller components than those in a steam cycle for the same power output. An alum cycle demonstration plant supported by industries and the U.S. Department of Energy, has been built and is under commissioning in the USA right now. Another is a project under development in Japan, which combines the gasification with fuel cell, which has the expected efficiency of 60%. There is another innovation in China to improve the efficiency of existing coal power plants. China has many 300 megawatts subcritical plants which are well maintained and are in good operating conditions. They have this idea to increase steam temperature to the supercritical level by using higher temperature components at the hot end of the steam, of the heat exchangers in the boiler, resulting in some efficiency gain. This is not technically challenging and are ready to be deployed, but the costs are high, which need to be justified. A demonstration project already shown the subcritical power plant efficiency has been increased to 42.8% after the upgrade. Work is still going on to optimize the equipment and design to make it more cost-effective. Considering the number of small subcritical units in operation in China and around the world, this technology can be a game changer if it can be made to work. This slide shows the major coal fleets of the world, and it shows the majority of operating units are inefficient subcritical systems, so there is a huge room for efficiency improvement and emission reductions. Over a decade ago, Japan and Western Europe led the way in ultra-supercritical deployment. China took it over, and the eighth pace of adding new ultra-supercritical power plants is unprecedented. Today, the vast majority of operating USC units are in China, but many other developing countries are starting to deploy HALE technologies. This slide shows the breakdown and the proportion of HALE plants under construction. China leads the coal power construction and the HALE deployment with over 2/3 of the generating units under constructions are USC. India is in second in growing its coal power capacity, but the majority of power units being built are supercritical instead of a state-of-the-art ultra-supercritical. By taking off China and India, this slide shows you a clearer picture of what is going on in other countries. Some developing countries lacking experience in such technologies, such as Bangladesh, UAE, Malaysia, and Morocco, are building a majority of USC plants. However, many other countries have failed to do the same. Right, deployment of HALE coal power faces many challenges, and you all know that. So we've seen increasing concern about coal use. Coal is also facing competition from gas. The low-cost gas in US limiting the opportunity of new coal plants to be built in the US in the near future. The government commitment to build power plants, appropriate local policies, regulatories, and the right economic and environmental circumstances are vital. For example, the policy driver in EU means new coal power plants are unlikely to be built in this region. The lack of sufficient economic resources means foreign cooperations are essential. Despite the challenges, there are potential opportunities. So economic growth and expanding populations are driving energy demand growth. And I like to stress, in developing countries, there are 1 billion people who are living without electricity, and a similar number of who have only limited access. And many of these countries are in Africa and South Asia. And they have limited oil and gas resources, but abundant coal reserves. So coal-based power generation is important to ensure secure and affordable power energy supply and to leave these people out of poverty. If we look in Asia, especially in the Southeast Asia, in Asia, over 50% of the world population live here, and there are far less than 50% of energy sources available to them. There are some fast-growing economies in this region, providing opportunities for highly technology to be introduced into this region. In fact, we have seen this being brought forward by China and Japan, each offering their own technology options and the financial support to enable this kind of plants being built and operated. And also in Europe, although Western Europe are phasing out coal, but some Central and Eastern European countries, such as Poland and Bulgaria, the coal power generation will continue well beyond 2030. If we look at in some countries in more detail for potential highly coal power plants, first, here is Bangladesh as a positive case study. It depended on coal power for many decades, and it has energy demand and production rising at 9% per year. As gas is running dry, so the country is looking at low-cost energy source, which is coal. They had almost no coal capacity, but now they are building UAC coal power plants with a total capacity of just over 3 gigawatts, with 11 gigawatts UAC plants in the planning stage. As a result, the share of coal in their power generation will increase from 2% to 50%. Since 2014, 62% of population has had access to electricity. More needs to be done to electrify the whole population, so potential for more highly coal plants. Pakistan has a similar size and geolocation to Bangladesh. It aims to reduce its dependence on oil by exploiting its huge lignite resources. In collaboration with China, Pakistan plans to add around 9.5 gigawatts capacity in the next 5 years. By end of last year, 3.3 gigawatts of power plants have come online, but all of them are supercritical instead of ultra supercritical, which is a missed opportunity. However, GE recently announced an order of 660 megawatts lignite-fired UAC plants. GE will provide the technology and be working closely with SEPCO 3. Pakistan has set a target to increase coal shares in power generation from 1% in 2015 to 19% in 2030, providing opportunities for highly coal power uptake. But the government needs to embrace USC technology. The potential for highly coal power also exists in some unexpected places, such as UAE and Egypt. 4 600 megawatts USC plants are under construction. The first unit is scheduled to come online in 2020. A 1,000 USC units power project is under development in Egypt. When built, it will be the world's largest coal power plant. So, the key messages are deploying highly technology for new and retrofit applications is a key near-term step in developing countries where coal is the preferred energy source. Countries where highly should be an attractive option have key similarities, but also significant differences. This will determine the realistic prospects for new coal power generation, and this needs to be understood better to ensure that coal is used in a sustainable manner for the foreseeable future. And thank you very much for your attention. And before I finish, I'd like to give you some information about this Clean Coal Technology Conference to be held in Houston in June this year. The confirmed speakers are from the major equipment manufacturer and technology suppliers. And you have the opportunity to visit the CCS facility in Petronova and also to see the NET Power's alarm cycle demo plant I just mentioned earlier. Okay, thank you very much.